everybody. My name's Fully,
I'm Indigo.
and we're smart contract developers at OlympusDAO. And we're here to talk about a framework that we've been working with called Default, and it's for how to design smart contracts. Okay, so why use a framework, and like what is a framework? So if you start writing code, most of the times you're not really thinking about the longevity of your code base or how you're organizing the different components of your logic. And when you're beginning, your project, it's not a big deal because the scope is very small. You don't really have a lot of features. You don't have a lot of external dependencies. So it doesn't really matter how you organize your code. But as the code base grows, as you add more developers, as you have more integrations, things can get very messy very quickly. And if you're building in more features, eventually you end up with very messy architectures. And sometimes you don't know where you can find your logic, and things can get very ugly. So we use a framework to increase readability of code, to make it easier to access for developers, and over the long term, it should make development faster, cleaner, make the code more readable, and things like that. So if you look at these two diagrams, don't get too intimidated, but this is a lot of what architecture can actually look like. So if you're a smart contract developer, you're working with different protocols, and you're trying to do an integration, a lot of times you actually end up looking at systems like this, and you're doing it from scratch. These are diagrams of architectures of protocols that we probably all have used, or at least know. The one on the left is MakerDAO, and the one on the right is Aave, or versions of them. And so, if you've ever done a yield farm, or some kind of lending integration, as a developer, and you're looking at these systems, it's very hard to understand where you have to call the contracts, what happens if you hit this one, it goes here, it goes there. It's very easy to get lost. So the idea behind our framework is to create a very clean and organized pattern for the system, so that if you call this contract, you know exactly where it's going, you know exactly what it's doing, and it's very easy to find. For both you, for your internal developers, if you're working with a team, for external partnerships, if they have to integrate with your system, it just makes it a lot cleaner and a lot easier for everybody. So that's the goal. And actually, maybe I should go a little bit over how this happens. It's a very natural thing. So I want everyone to know I'm not criticizing this architecture. When you're not using a framework to design your code, it's very easy to use just processes, one by one, and you kind of add them together and you chain your logic, right? So maybe you have a lending system and you have a lending pool, and then the lending pool has a manager, a lending manager, and the lending manager has an asset controller, and the asset controller has something else. And so your brain naturally thinks like this. It's very process driven. And the problem is, you want to add a new feature, then you have this new manager, this new controller, this new thing, and you just stick it in, to the next part behind the chain, and next thing you know, you just have this whole web. So what we want to do is we want to take a top-down approach, kind of a more holistic idea of what are the different parts of a protocol that are important for us to develop, and then how can we categorize them into, an organizational structure for our logic. And this is default. Yeah. So you can kind of see the goal is to condense the architecture, turn it from a web where you have all these different, unconnected nodes that all connect to each other, to kind of a stack. And with the stack, at the top, you have these policies. In the middle, you have this kind of kernel, this controller, and then at the bottom, you have modules. And then, yeah, I'll let Indigo talk a little bit more about what each of these do and kind of how we use them at Olympus.
Yeah, so the first implementation that we made of this framework, it was Olympus v3. We did this, I think, a year and a half ago, and we've been working on it slowly. So this is actually the Olympus v3 initial version. So the first part of the default is the kernel, which acts like a central registry for all the contracts, policies and modules, all register with the kernel. Then we have modules, which are like state stores of any state for the protocol is stored in the module, and anything that's shared across the protocol. So you can imagine like a treasury, a minter contract, anything like that is primarily a module. And then lastly, we have policies, which act like user interface for the protocol. So like a vault contract, anything like that is a policy. So the kernel is primarily restricted down to 6 actions, and this is what allows us to stop the growth of complexity that we see in like the Maker and the Aave contracts. So as you can see, there's the install and upgrade module, there's activate and deactivate policy, there's change executor, and migrate kernel. So the first 2 are just for installing and upgrading modules. This is very simple. As you guys know, changing out contracts is always necessary. Activating, deactivating policies. So policies are kind of act like, you can think of them like scripts almost, or things that are, they're like completely immutable. If we need to change a policy, we just deactivate it and change it to something else. And the reason why we can do this is because the state is inside the module, so we don't have to do any kind of like migration or anything. And then lastly, we have the change executor. So the executor is primarily the governance contract or the multisig that has control over the protocol. And this just allows us to change out who's in control, essentially. So for now, we have a multisig that's our executor, but when we deploy our governance contract, we will change the executor from the multisig to the governance. And then lastly, we have the migrate kernel, is just so in case we need to change the kernel, or if there's a bug or something, we can change it out. Okay, so this is the module contracts, and I apologize for non-devs. This is a presentation for devs, but I'll try to explain it like in a non-technical way. So the modules act as like internal state stores for the protocol. So and we denote these modules by key codes, which are like just five letters to just so we know exactly what we're looking at right when we see the module. And when we upgrade the module, we keep the key code. So you can almost think of it like how proxies are done for upgradable proxies. You have a proxy that points to an implementation. It's very similar conceptually to that. So the module is it's just shared state. It's generally very simple. So like an example of a module that we have is the treasury. So the treasury holds assets, and it literally just holds assets. So any kind of logic for the asset of like allocating it to a different protocol, farming it, or like trading it, whatever, that would be implemented in a policy above. But the state of the asset stays inside the module. So module is pretty simple. Policies are where we encapsulate a lot of the complexity of the protocol. So we try to do any kind of, as I said, like swapping, allocation of assets. This policy this is the most complex one we have in Olympus. It's the operator policy. If you guys know what we do, we have a, apologies, I got it. We have a bunch of assets in our treasury, and what we do is we use the assets to defend the price of Ohm. So when the price is above a level, we sell Ohm, and when the price is below a level, we buy Ohm using our treasury assets. So as you can see here, I don't know if you guys can see in the back, but we have four modules that we're pulling in. So one defining feature of default is that, and one of the biggest things that we wanted to emphasize was that when a policy gets installed, you know exactly what you're looking at and what you're getting right when you look at it, right when you install it in. So right up front, this is the main 2 functions. You see that we have 4 modules that we need, and then we know exactly what functions the modules are calling, right from the start. So this is very different from like integrating a different protocol where you don't know exactly one call is calling what, like how many levels deep it goes, how many different protocols it's calling. Nothing like that. We know exactly what we're looking at and what we're getting right when we look at the policy. So yeah, we pull in the 4 modules, and then we have the functions that we're calling right below. So just to go over some examples of the Olympus v3 code base, is obviously very simple to look at. The core of the protocol is just the treasury and the minter module below. So the treasury, as I explained before, is just the asset store for the protocol. And then the minter is how we actually mint the token if we need to. And then we have a treasury custodian that's like a policy that just manages the treasury contract in case of like whatever issues that we need. Sometimes we have to do a swap or something like that. So that's what we use the treasury custodian for. So the range bound stability is what you were looking at earlier on the policy slide. The range bound stability is the contract that actually does the price controls for the token. And as you can see here, it's like very easy to understand. Like, okay, it's 4 different modules on the bottom, and there's 2 up here. There's a bond callback and the operator. These are the policies, and these are the entire system is this. Like, the system is like fairly complex, but it's very encapsulated into just those 2 policies up there. You don't actually have to worry too much about like what's happening on the modules. You just look at the operator. You know, the functions are very clear. So you look at the operator, you know exactly what it's doing. This is very different from like other code bases I've seen where I don't exactly know like how deep the call stack goes or anything like that. It gets really complex really fast. So. And then, yeah, fully go over governance.
Can you guys hear me? Cool. Yeah. On the governance side, also very simple. So we have our entire on-chain governance system encapsulated with these 3 contracts. For the modules, we have votes and instructions. Votes just keep a track of how many votes an address has. So it's just a voting balance, like ERC20 token that's non-transferable. Instructions are just the actual like executable code for the proposals in case they get passed. So what is actually going to get called, and they're all kernel instructions, right? So it's like the proposal could be install or upgrade the treasury, install a new policy, and do something else. And that will be a proposal that gets stored as an instruction. And then the actual business logic around like the governance, the voting, the consensus mechanism, when does a proposal pass, how does it pass, what's the quorum, that all goes into the governor. And so if you want to change your governance logic, business logic, like, okay, you know, we want to change the way we count votes. Maybe we want to, you know, have a super majority instead of just a simple majority. Maybe we want to use like a delta, you know, voting system instead of just like a majority voting system. Those are all things where like you don't have to touch the vote, the ERC20 votes. All you have to do is say, okay, disable the old governor policy, activate a new governor policy, put it in, and all of the dependencies will automatically link. So it just makes upgrading the system a lot more clean, a lot manageable, and also, in my mind, more transparent. Yeah, so we experience this a lot, right, where like we want to change how our systems perform, you know, functionally speaking, but when we do it, it's very hard to like move things in and out. You have to unplug and plug a lot of your dependencies. And so we kind of developed this way for us to be able to, you know, upgrade our business logic, you know, without having to manage a lot of the, I guess it's like DevOps side, the Web3 DevOps, I don't know. But yeah.
All right, so we gave this talk in November when we had just first launched Olympus v3, and it's been like months since. And so I just wanted to share some of the things that we've learned and like what actually we're working towards and why. So one of the biggest things that happened was that because the system is like so modular, we actually were able to do like almost 6 different development efforts in parallel, which is if you go from like Web 2 or like a different field of software engineering, this is very common, but like it's not something we generally get in contracts development because everything is like so tightly coupled. Because we were able to separate all the logic and everything, we actually had like all these different things going on at the same time, and there's very little like oh, you know, are you using this contract? Are you changing this? It's not like that. It's very easy actually to work as a larger team.
But we didn't even realize like how nice it is. At Olympus we have like maybe one weekly stand-up where we just go over what we're working on, and each dev has like a completely different like feature on their own. You know, some guys doing like an accounting system, some guys doing governance, some guys doing like aggregations or, you know, liquidity vaults, and all we have to do is say like, yeah, this is what I'm working on. The cost of coordination is very low because of the way that, yeah, we like have this structure. I don't know.
So the other thing is that we have like the code base is extremely easy to understand. We've heard this from like multiple people, from auditors, from other people who've just looked through our code. And that's like, as a dev, is a very nice thing to hear. But actually the biggest goal that Fully and I, the reason why we wanted to implement this architecture was because our vision for protocols is actually to be like truly decentralized, not to have a DAO that's like like a pseudo corporation organization that's like managing contracts with multi-sigs and stuff. We actually want the whole system to be completely decentralized, where anyone can just come in, plug into the system, and all you have to do is like convince voters. You don't have to convince like the BD team or the partnerships team and then tell the devs to integrate your contracts. Like, no, we want you to be able to write a contract, you propose it as a proposal, and then it goes to the governance system. Everyone sees it, everyone's able to understand exactly what it's touching, what it's doing. The auditors are able to audit what it's doing, and then it just gets voted on, and then it gets added into the system. I don't think we have anything like this right now, and this is one of the reasons why we built this system. And we know it's not perfect. There's a few things where there are some challenges with it, but I think the system is like, it's the first iteration in something that actually leads to like a true DAO.
All right, I think we can open it up for questions.
Thank you. Wonderful talk. And then, well, since you mentioned the challenges, I want to like, if you can elaborate on those, like what kind of challenges that you already see right now, and perhaps what are you thinking of how to address them?
Okay, he asked what challenges we're facing. So the challenges we face right now is like sometimes there's a little complexity because the structure is like, you know, one stack deep. Sometimes you want like more complexity in like the modules, and you don't really know where to put it. So we've been thinking about like adding a third layer to the system at some point. That's for like data aggregation or things like that. We're trying to really solidify exactly the use case before we go towards that. Do you have any?
Yeah, sure. So like, I can give a little more detail. It came in with the on-chain accounting system, but there was something where we needed to use data across different modules, but we didn't want to abstract it into the policy because of a way that we were doing a callback. And so we were thinking like, okay, do we allow some, because modules normally cannot talk to each other. They all have to go through policies. But this is just purely for like data aggregation. So we're like, do we make an exception? Do we not? And we went back and forth. And so the solution that we're exploring is actually what Indigo said, like a third layer. And the third layer is a query layer, a query contract that basically just gives you a read value with business logic. And then it might have its own kernel actions, and that way you can just upgrade that without having to worry about anything else. And the benefit I see with this is actually very similar to how we think about upgradable proxies, where like we can keep our policy contract addresses the same, and then if you want to change the calculations for your bonding curves, you want to change like your slopes or anything like that, you can just change the query contracts, and you don't have to touch the policy logic or the data models, and yeah, it should work. So. That's currently in development. So
I'll just add, the other thing is that the system, obviously, since you're splitting the logic across different contracts, you'll have like more gas costs trying to call, if you're calling like a ton of different things. But I will say that like, when you're calling a module, you know that it's not calling anything else. So it's just one single external call, right? And was that? Oh, so yeah, it's just it's not actually as bad as like people think. And also, one thing that Fully and I decided was like, we don't want to design for the current constraints. We want to design for a true system that can work with like future constraints, which I think gas will be much lower in the future, and like I don't think it'll be as much of a problem.
So I really like the idea of anyone coming up with a proposal to just stitch together these modules to basically implement the proposal. Are you guys have you guys thought about like a tooling at a meta level for non-coders to just like stitch together modules, and then that generates code, and that implements the proposal, and that way it's also easier for the community to know that a proposal is implemented correctly.
Yeah, I actually got this. So, two things I want to say actually. One is, basically like, we hope that if anyone wants to use like the Olympus liquidity or treasury for their own project, you don't have to go through anyone. You don't have to go through the partnerships team and know someone and say, hey, can the dev set this up? Can you get this? So we're actually going to pilot an on-chain governance demo, and we're going to deploy a copy of the protocol, and we're going to inject it with, some incentives. I don't know exactly how much, but should be like decent size. And the idea is anyone can come in and buy votes and use it to submit whatever they want, and we'll just kind of see what happens. But the idea in the future is we can actually create like policy factories. So maybe someone from an Olympus team or someone else can say like, this is a template for pulling liquidity out and using it to allocate it into a farm. And that might just be like a vault structure, or it might be like some kind of template. And then all you have to do is like initialize the constructor with like, this is the target address, this is the allowance that you can get from the treasury. And so then we just have to look at like, okay, based on the parameters that you put into the contract, this is what we know it's doing. And then even if you don't know code and you say, well, I have an idea, I want to do like an allocation system for the treasury, then you just have to deploy a copy with what your target variables are, and it should all go. So that's something that we're thinking about. I think it's going to be a little bit ways out, because we have to make sure that the governance system and everything is more mature. But yeah, in terms of safety and accessibility, like the whole reason, as Indigo was saying, the philosophy behind this is so that everyone can participate in protocol governance and feel like, as a stakeholder of this system, they actually can make a decision about where the money goes and what it's doing. And I don't feel like, we have a lot of protocols that give us that feeling today.
All right, next question from this fellow.
Yeah, just one question regarding the interaction between the different contracts. Are they each like deployed separately and have their own storage and just have like normal calls in between, or is it like delegate calls or some kind of shared storage?
It's just regular calls.
Okay.
Yeah.
No delegate calls in the entire system.
Not yet.
Yeah. So everything is explicit flows.
Yeah, it's just regular calls. So the way that it works is that the kernel is the registry. So like anything that needs that dependency, it just requests that dependency from the kernel. So we know exactly. So the kernel knows exactly what it's sending to the policy that's requesting it. But yeah, it's just a regular call.
Yeah. So each one of these is actually deployed separately. So when we like deployed our system, or if we're trying to like test it. You just deploy the operator policy, deploy the bond callback policy, and then you go through each kernel action and you say like, install this, install this, install this, approve this, approve this, approve this, and then you get the system in completion. Okay.
It's actually it's funny because like we didn't actually use like any fancy anything. There's no delegate calls. There's like we didn't actually use like much assembly. There's like all these other frameworks use like dynamic routers and all kinds of craziness. Like the system is like dead simple. If a new dev looked at it, they would know exactly what's going on very, very fast.
All right, I think we can take final question if there's any. We're gonna have another 5 seconds. All right, nice talk. It's mind-blowing for me. I enjoyed it. So thank Indigo
Thank you,
and
everybody.
Ollie.